Let's take a look now at example number 2. I want to go ahead and find the antiderivative of the function x over the square root of 1 minus 4x squared. Oof, okay. Well, again, is this a derivative rule that I know from earlier? No, I mean the square root on the bottom might, with the 1 minus, might start making me think about inverse trig, but I don't think this actually fits the appropriate form here. Okay, well, any algebra I can use to rewrite this? Nothing really seems to pop out. So, okay, so how about I go ahead and I start thinking about making a u substitution. Again, I want to select something in here so that way I see its derivative in there as well, multiplied to that dx. So here a good choice that I might see is something like 1 minus a 4x squared. Now to see why, let's take a look at what happens when I actually compute this derivative. My derivative here is going to be negative 8x. So if I was to multiply my dx over to the other side, I would say that du is equal to negative 8x dx. Now in my integral, I obviously can replace this inside of the radical with my u, but I don't really have a negative 8 times an x times a dx. But I do have an x times a dx. So if I rewrote this one more time, dividing both sides by 8, or negative 8, I could see that x times dx is equivalent to negative an eighth du. So this seems like a substitution that might work. Let's try it out. I can go ahead and see that underneath my square root, again I'm replacing the value of u. In place of my x times my dx, I'm plugging in a negative 1/8 and a du. So I now do have an integral that only contains u's. Let's see if it's an easy integral to work with. Okay, I'm going to use a little bit of rewriting capability here. I'm going to take this negative an eighth and I'm going to pull this out to the front. And then I'm also going to recognize that that would leave me with 1 over the square root of u. I'm going to use a little bit of algebra here to rewrite this, because I think I can rewrite that as u to the negative 1/2. And is that a derivative rule that I could undo? Oh, yes it is. I could go ahead and just reverse a power rule here. I could add 1 back to the power, and I could just put a 2 in the front. Notice again, if I took the derivative here, the 1/2 comes down, cancels the 2, and I'm right back to where I started. So I'm going to have this plus c. So notice then that gives me a negative 1/4 if I simplify the 2 and the 1/8, u to the 1/2 power, or you could write that as, instead, a square root of u. And now, I just have to make sure that I substitute everything back in terms of x's. So this would look like negative 1/4 square root, and u was 1 minus 4x squared. Don't forget, plus c. And again, how can I check my answer? I can check my answer by taking a derivative.